In this video, we're going to look at several examples of writing quadratic equations from a given graph. And I'm going to write most of them in standard form, vertex form, and intercept form. Some of them I won't write in intercept form because some of them don't have real number intercepts. We'll look at that more when we get to another example. Please make sure that before watching this video you are familiar with vertex form and intercept form. Our first graph here gives us several points. We know that there is an x and y intercept at 0, 0. There's another x-intercept at 2, 0. And it looks like the vertex is at 1, negative 1. So in vertex form, we can write this as y equals a times x minus 1 squared minus 1. In intercept form, we can write this as y equals a times x minus 0 times x minus 2. The last thing we need to figure out for either of these is the a value. Let's use the vertex form and plug in one of the intercepts. We'll plug in 0, 0, because zeros usually cancel out really nicely. We'll plug in 0 for y equals a times 0 for x minus 1 squared minus 1. 0 equals a times, well, 0 minus 1 is negative 1. Negative 1 squared is positive 1. Minus 1. 0 equals, well, a times 1 is just a, so a minus 1 equals 0. Adding 1 to both sides gets us that 1 equals a. So in this case, we know that a equals 1. That means that our vertex form is y equals 1 times x minus 1 squared minus 1. Notice I didn't write the a equals 1 value in there, because if I'm multiplying by 1, it's just understood to be there. Now, intercept form, okay, is y equals that understood to be there 1, and then I'm going to take this x minus 0 and just write it as x, because x minus 0 is x, times the other factor, x minus 2. The last thing we need to do is transform either one of these into standard form. Probably the easiest one to work with is intercept form. Remember, standard form is ax squared plus bx plus c. It's when everything's multiplied out from either vertex form or intercept form. So I'm going to take intercept form and just distribute this x. So x times x is x squared, and x times negative 2 is minus 2x. So here are our final answers in 3 different forms. For our next example, we are not going to put it in intercept form. Take a look at the graph. Where are the x-intercepts? They aren't here because they exist, but they're not real numbers. They can't be plotted on a traditional xy coordinate plane. So we can't write this in intercept form with real numbers because the intercepts are imaginary numbers, which is something you'll learn about in Algebra 2. So let's take a look here. Our vertex seems to be at 1, 3, and it looks like our y-intercept is at 0, 5, which means there's also a point over here at 2, 5. So let's start with vertex form. Y equals a times x minus 1 squared plus 3. Only thing we need to do now is find that a value. So let's plug in the y-intercept 0, 5. 5 is the y value. A is the unknown we're looking for. The x value is 0. 0 minus 1 is negative 1. Negative 1 squared is positive 1. So this is 1a, or really just a, plus 3 is equal to 5. Subtracting 3 from both sides, we get that 2 is equal to a. So in vertex form, our answer is y equals 2 times x minus 1 squared plus 3. And remember, to get standard form, we just need to multiply everything out and combine like terms. So y equals 2 times x minus 1 times x minus 1 plus 3. Y equals 2 times x is x squared. X times a negative 1 is negative x. Negative 1 times x is a negative x. And negative 1 times negative 1 is positive 1. And we still have our plus 3 out back. So this is 2 times the quantity x squared minus 2x plus 1, and then plus 3 behind the parentheses. So we have 2x squared, I'm distributing this 2 now, minus 4x plus 2 plus 3. We'll combine the positive 2 and positive 3 when we write it up here in standard form. Y equals 2x squared minus 4x plus 5. So here are our 2 final answers, one in standard form and one in vertex form. Our next example does have real number x-intercepts. They exist here and here. However, Because they aren't whole numbers, we're not being asked to write intercept form here. So it's possible to write this in intercept form, but pretty complicated, so we're not being asked to do it in this case. So instead, let's take a look at the vertex, which is at 1, 3, and the y-intercept at 0, 2. In vertex form, this is y equals a times x minus 1 squared plus 3. And to determine the a value, we'll plug in the y-intercept 0, 2. So the y value is 2. A is the unknown we're looking for. X is 0, so we have 0 minus 1 squared plus 3. 0 minus 1 is negative 1. Negative 1 squared is positive 1. So this essentially all cancels out because positive 1 times a is just a. So a plus 3 equals 2. Subtracting 3 from both sides, we'll get that negative 1 equals a. So a in this case is negative 1, which remember makes sense because if a is negative, less than 0, the parabola is going to open down just like the graph does here. So our vertex form is y equals negative x minus 1 quantity squared plus 3. And to get our other answer, we'll need to multiply all of this out. So y equals negative. We squared x minus 1 in the last problem, so I know that it's x squared minus 2x plus 1 with a plus 3 out back. So we'll distribute the negative through to the parentheses. We'll get negative x squared plus 2x minus 1 plus 3, which gets us y equals negative x squared plus 2x plus 2 for our standard form. In this example, we're back to also being asked to do intercept form because the x-intercepts here are clearly marked integers. So we have an x-intercept at negative 1, 0. We have another x-intercept at 5, 0. And it actually has already marked for us that our vertex is at 2, negative 9. And notice that that's actually changed the scale a little bit. So they've gone out 2 on the x-axis, but they've gone down 9 on the y-axis, which means that each tick mark I just drew there actually represents 3 units of distance. So we'll write it in vertex form and intercept form and solve for that a value. Vertex form is going to be y equals a times the quantity x minus 2 squared minus 9. And our intercept form would give us y equals a times the quantity x minus a negative 1, which remember gets us x plus 1 times x minus 5. So we can use either one of those to solve for the a value. Let's use intercept form this time since we haven't had a lot of practice with that. I'm going to use the vertex 2, negative 9. So I plug in negative 9 for y. A is the unknown we're solving for, and now there's 2 different places where for x I need to plug in 2. So 2 plus 1, and then 2 minus 5. So negative 9 equals a times 3 times negative 3. So negative 9 equals a times negative 9. So we'll divide by negative 9 on both sides and determine that a is equal to 1. That means that in intercept form, our equation says y equals x plus 1 times x minus 5. Remember, if my a value was 1, I don't need to write anything out front of these vertex and intercept forms. Vertex form is going to be y equals the quantity x minus 2 squared minus 9. And standard form is either one of these multiplied out. So I'll take intercept form and FOIL it. So x squared plus 1x in the middle and then minus 5x is going to get us negative 4x. Positive 1 times negative 5 will get us negative 5. So here are our 3 equations for the same parabola written in 3 different forms.